Okay, good morning. You can all hear me?
Yes, bro.
Yes.
Yeah, we could hear you.
I can't hear you now.
Professor, we cannot hear you at this moment.
Professor, we can't hear you now.
Okay, let's try again. Can you hear me now?
Yes.
Yes, Doctor.
Okay,
bro.
so let's hope
Yes, doctor.
this lasts for the rest of the time. Otherwise, it will be very annoying. There's more people requesting to join. No. Okay. As I was saying, we have 14 weeks. We have 11 modules. Every module has its learning outcomes. For today, the learning outcomes are first to explain the characteristics and objectives of conducting a systematic research work. So we are really looking into the research part, right? Differentiate various types and research methods. So again, research with their respective features. And then regarding PhD, state the motivation for rolling into a PhD program and provide basic information on PhD program enrollment. So this is for today, right? The outcomes for today. And of course, we will also take a look at the course as such. Some of the materials, and if you look for research methodology for textbooks, it's actually surprisingly hard to find a unified source on research methodology. So this has been grabbed together from a lot of different resources. Most of this has been set up by Prof. Aziz before me. I've just taken over from him. So what we will do a lot this course is do some activities. This will be the first one where I just open a question and I give a few minutes for you all to brainstorm or to come up with answers. What words, in this case, what words come to mind when you see or hear the term research? When you see or hear the term research, what is the thing that comes to mind, the words that come to mind? Investigation of new concept, right? Experiment, very good. Another one, experiment, problem solving, data, study. Google Scholar, very good. Analysis, paper, learning, data, another data, discovery, input and output data, curiosity, innovation. I see there's a lot more people typing, but not sending. Validation, novelty. Peer review. Publication, yeah, we've seen publication. Okay, I see. I don't know why this is in a different window, but develop, cooperation, finding new ideas, defining, redefining problems, in-depth understanding of subject matter, data collection, systematic study, methodology, yes, systematic study, very good. Formulating hypotheses, novelty, collecting, organizing, evaluating data. We have work to do. Maybe this is a reminder to me that you have more important things to do. Finding, come, academic, systematic studies, breakthrough, exploration. Okay, so that's a lot. Thank you very much all. Drawback. Drawback findings? Sure what that is. Make change happen. Evaluation. Okay. So, logical reasoning. Yeah. So thank you very much all for this wonderful participation. There's a lot of elements that you have hit on, right? You say, for example, problem solving. That means there is a problem to begin with, right? Discovery and a breakthrough. So there is something new, right? And I've also seen systematic, which is also important. So the elements that go into research, according to definition, is that research is a systematic approach to obtain and confirm new and reliable knowledge. So the keywords are highlighted in red, right? Research is a systematic activity. You can discover new things just by chance, but that is not considered research, right? Of course, we do not research something that's old. I mean, you can research something that is old, but the knowledge that you gain from it should somehow be new, right? Otherwise, it is not research. And it should be reliable. Because you want to, as you highlighted several times, paper, publication, peer review. So there should be a reliability in the new knowledge. So I think we have hit all of those elements in your activity, which is good. Another person want to join? Yes. Okay. Now, since there are a number of things that go into research, think maybe in your field, maybe not in your field, maybe from your country or whatever, a researcher or some research work that you really admire and that you want to maybe emulate, or that's an example to you. And if you can, please explain it. Chat. My window go now. So I see Bikash Pal because he has done innovative work on power system stability. I guess this is electrical engineering then. Researchers, Kanich Ahmad. Which researchers? Okay, that's the question. Albert Einstein, Thomas Edison. Okay, those are of course very famous people. Any particular research of or approach of theirs that you particularly like or admire? So you mentioned Dr. Azhar. So she's maybe your supervisor. That's good if you really admire your supervisor. That's a good motivation to your study. Yeah. John Percy improved steelmaking methods and wrote a classic treatise on metallurgy. Right. So it's a very practical, very important research. The engineer who invented the AC. Yeah, we are using the fruits of that knowledge, right? Many breakthrough in frontier research and inventions. Oh, this is still relating to Albert Einstein and Thomas Edison. Okay. Bruce Logan from Penn State on his work in MFC, turning wastewater into electricity. Okay. Intel's 18A Advanced. 18. You get that. Sigmund Freud and Carl Jung on human mind dynamics. Yes, they have done some interesting things, right? It's a bit old-fashioned now. Johann August developed hardness testing, the Brinell hardness test, right? And we still use that for steels, right? P. Kundor for stability. Stability of what? Paul Dirac for quantum mechanics. Yeah, interesting figure. It's done a lot on the mathematics for quantum mechanics, right? Develop, I admire the most work that related to sustainable and green buildings. Yeah. Susumu Kitagawa, Richard Robson, and Omoriagi. Oh, the MOFs for rare earth capture and so on. Yeah. So Nobel Prize. Geoffrey Hinton, pioneering work on artificial neural networks, which revolutionized the field of artificial intelligence. Or you might say it started, because before that there wasn't much. Somebody wanted to speak? You can speak as well if you want to. Motion analysis. Okay. Werner von Siemens, technology and engineering innovation. Okay. Colleagues. Okay, that's a good one there, Rahana. This one, because Dr. Asa has implemented many approaches involving technology in the rehabilitation process. I see. Okay. And you have a disability, a spinal cord injury. Okay. Yeah. Yeah. Geoffrey Hinton from Neural Networks. I think we've seen him just now. Heisenberg for his uncertainty principle. Habibi for the most significant contribution in the field of aerodynamics. Okay. So there are many, many people to admire, to emulate, to read the work, to make use of the work. Directed evolution of enzymes. So mostly the people phase transformation in metals, right? Mostly the people we admire have opened up a new field or really generated a breakthrough or given a new direction, right? The real pioneers are the ones that we tend to remember, even though I see there's a lot of contemporary idols here who you admire, which is also good. MICP for soil improvement. Okay. Oppenheimer. Yeah, you watched the movie? Yes, we went to the movie also. I think it was 2 years ago, something. Yeah, it was nice. Okay. Thank you. So there has been a tremendous amount of research in the past. We have to learn it, right? We have to read the literature, and we will see some of the researchers really speak to us because we really admire what they did. Today is really activity heavy. So there's a statement here. The statement is we are all involved in some form of research activities every day. Do you agree with the statement? And of course, if you say yes or no, explain why or why not. Yes, search for information online. Yes, we search on personal growth based on real life event. Every day have new things to learn and research. Okay, but are we? The question is, we are involved, right? We are all involved in some form of research activities every day. Do you agree with that or not? It's research based on problem, latest issue, busy in research about just something. Adjustments in new. Yes, okay, please try to share your reason for saying. Otherwise, it's just there's just two options, right? Yes and no. We want to learn a little bit more. We're seeking information, learning, solving problems. So that means we are engaging in research. Okay, we try new recipes to see which taste better. So that's kitchen science, right? When you test a recipe, change the ingredients, that's research too. Okay, you two are working together. For example, when we compare products before buying, so this is market research, your study on Shopee and what are they all called? Taobei, Taobao. Daily activities, each one is an exploration, summary, and accumulation of experience. Mhm. Every day we are involved in some form of research, searching for information, trying to solve a problem, learning new things. We are the object of some research. Ah, that's the opposite. People are researching us. Okay, especially looks like the big data. Huh? So probably what I say now, because Microsoft is transcribing it as I speak, and it will probably end up training some large language model somewhere. So I should say something weird once in a while to just throw them off. So I see a lot of people writing in live captions, but it never appears in the chat. Please do share with everyone, okay? When I go somewhere new, I need to research the map and places. Every day we research, even when we Google what to eat. Okay, so you search out new places, new restaurants, or maybe even just where that restaurant you want to go to is open, right? Okay, so a lot of yes. Two more people to accept in. A lot of yes. On a daily basis, as simple as traveling to get to from point A to point B. We will do research on the shortest road, less traffic, less time taken. Yep. Okay. But since we're talking about research, you should also consider whether all those examples you gave really reflect a systematic approach that are aimed at creating new and reliable knowledge. Right? So we are doing new things every day, but are we doing it systematically? And are we doing it in such a way that we're creating reliable knowledge? Yes. Define problem. Question, where should I stay that is safe, affordable, and close to attractions? All right. Collect data, read travel blogs, compare hotel ratings, look at maps, check public transport routes, analyze and conclude, book the accommodation that optimizes the variables. Okay. So that's very systematic. Right? Very systematic, and if done well, hopefully reliable. So the outcome should be that you enjoy your holiday. Right? Very good. Writing review paper. I was saying writing review paper is your life as a PhD student, but it's not what people normally consider daily life, right? By asking the question, we are all involved in some form of research activities daily. We really mean general daily life, not your daily life as a PhD student. Cook a meal need a systematic process. Is that so? Let's say you want to develop a new recipe. If you do it systematically, you would vary the amount of whatever butter or spice according to some set levels, randomize your experiment, cook the meal, have a test panel taste it according to some kind of rubric that you define, and continue the research accordingly, right? That would be systematic in my view. If I try and develop a new recipe, I just throw everything in the pot and I see what comes out. Not necessarily systematic. Systematic thinking starts with daily decisions. Mm-hmm. All right. So yeah, actually, all very good contributions. So don't let me cook because I'm not a systematic cook. Right. Okay. So what is research not? Okay. Research is not accidental discovery. You walk somewhere, you trip, you fall on your nose, and you say, "Oh, from my research, I've learned I should not walk here." That's not a research, even though maybe you think you've learned something. It's an accidental discovery. It's not outcome of a systematic experiment, right? So accidental discovery is not research. Only data collection. And believe it or not, sometimes we do see even PhD theses where students have collected a lot of data. Yeah, because what was the definition of research? The definition of research was to generate new and reliable knowledge. So if you collect a lot of data, but it is not connected to some new and reliable theory, theorem, thesis, whatever outcome, it's not research, right? It's just data collection. Research is not only for publication. Okay. I know we stress publication a lot, but publication is the outcome of research, right? One outcome of research. The research itself is the systematic pursuit of new and reliable knowledge. So, example here. A young man consumes the same type of cereal for breakfast for about 6 months, and his weight reduced by about 5%. He concludes that eating cereal reduces weight and therefore it is a healthy product. Is this a reliable research discovery? If yes, why? If no, why not? Nope. That's very quick, Simeng, but maybe you can explain a little bit more. If you say no, what's wrong with it? All conditions have to be studied, meaning data is too monotonous. Too many variables involved, I see, from Chen Haoyi. Already exist, so not new, okay? This personal opinion, there could be other reasons for the weight loss. Too much generalized. There are other factors, not just cereal, cause weight loss. For example, metabolism that related to age. Okay? All reasons for weight loss. What other things is he eating? Because this was only breakfast, right? This is only breakfast. So what other things is he eating? His activities. And here in the thing I also see Chen Haoyi, exercise expenditure, dietary intake, physical conditions need to be considered. Right. Require a larger sample size, control group, consistent measurement methods, statistical analysis. Right. So maybe we can start to summarize. It's not systematic. Okay? It's not systematic. We have a young man, only one young man. So our sample size is 1, which makes it automatically very biased because he is young. There are no elderly people involved in the study. He is a man. There are no women involved in the study. So, of course, taking the average will be very easy because it's only 1. You have nothing to do there. He consumes the same type of cereal for breakfast. So there's only one type. Eventually, the conclusion is eating cereal in general. That cannot be, right? For about 6 months. Well, that may be long enough for a study. And his weight reduced by about 5%. Yeah, this may be reliable, right? His weight has reduced by 5%. You can just measure that on the weighing scale. But as you said, there is no control group. You need a group of people who continue to eat what they eat before. You need a group of people who eat this cereal, and you need to control some other variables to keep everything within statistical logic. You need to do the statistical analysis as well. Right. Only one sample, larger sample size, correct. Reliable for that one young man only. Well, even that, Hannah, how are we sure that the cereal is the only change he made in his life, right? Young people change pretty fast. So if before this he had a different type of breakfast, now he switches to this cereal. Surely in these 6 months, he also has other changes in his life. So it's very difficult to say that this weight reduction has something to do even with this cereal. There could be so many other reasons. So even for this one man, it is not reliable. Simple analysis is not convincing, right? It should be more in-depth analysis. Control the variations and so on. Yeah. And this is a general thing, right? We either need to have a very clear idea of cause and effect. That will sometimes help, but if there is any doubt about that, we just need numbers. You need a number of test subjects and statistics. Okay. And we have another person want to join. Okay. Done. Now, why is research important? Prof. Aziz referred to a study of Calmorin and Calmorin. I tried to find it last semester. I think I couldn't. It improves the quality of life. Right? It improves instruction. So, of course, when we make new discoveries, we can use those to improve the quality of our life, right? So yeah, it improves instruction. So a lecturer who is also doing research will be able to teach better, right? It improves instruction. It improves the achievement of students compared to just opening a textbook and learning. If a student does research, they will do better. It satisfies human needs. It reduces the burden of work. So we can use the outcomes of research to make our life easier. It's related to quality of life. Has psychological aspects because it's satisfying, right? We have found some new knowledge. We are satisfied. We are proud of ourselves. We are relieved that finally we know how something works, etc. And I think this was the reason why I wanted to find a particular article. It improves the exportation of food products. A very somewhat odd point. So maybe if one of you can find this article and send me, I would be interested to find out what is this food product thing about. Okay. So if you think of your individual PhD title, because I think you all have at least your title already, right? What would be the possible contribution from your PhD work to the world in general, right? Enabling copper. I don't understand that. Helping disabled people make their life easier. All right, that's absolutely improvement in quality of life. Right? Easier way to prevent blackout. All right. Enabling copper. I do not understand that. Improve highway safety. Oh, copper to copper bonding in advanced packaging. Okay, I didn't see that. More energy efficient more efficient energy usage in buildings by developing adaptive control algorithms. Right? So energy savings. Improving healthcare system, reduce medical personnel burnout. In situ drinking water for rural areas. So that's a safety and health issue as well. Reduce the workload of doctors. Is it the same person? No, it's a different person. Improvement in sustainability sector. Satisfy human needs. Optimize electricity grid operation in high fault current situation. Energy and cost efficient solid state recycling of aluminium alloy AA6063 by optimizing deformation parameters. Help people in offshore to have access to clean water. Oh, seawater desalination. Also very important for the Middle East desert regions where they have no access to fresh water enough. Existing power, more efficient, reliable, suited to power generation. Wastewater treatment, ergonomy for machines. Heat transfer using nanomaterials. All right. Make people don't suffer from insomnia. Okay, it's important. Solar energy efficiency, eco-friendly, low-carbon construction, power system grid availability. All right. So I didn't really count whether everyone has written, but in some way or other, especially because we are engineers, right? We create something to enhance the quality of life. Cleaner production pathway. Either very directly by saying, I want to help people don't suffer from insomnia, or help people with a disability have access to things, or in a slightly more roundabout way by saying energy efficiency, help combat climate change, and so on. Seniors and non-expert use of IoT, right? Because very soon we simply can't live without all the technology anymore. And elderly people need to keep up with that. Yeah, very important. Distributed acoustic sensing. All right. Bridge the gap between technological innovation, real-world use of functional electrical simulation in community-based rehabilitation settings, ensuring more inclusive and effective rehabilitation practices in Malaysia. Okay. So that is people, we say functional electrical stimulation. So I guess people lost some muscle function and should get it back through rehabilitation. Right. Okay. Very good. Want to move on. Later, when I go through the course page, I will tell you that you will all get a few minutes to introduce your work to me and everyone else. So you can highlight probably the possible contribution as one of the things in the 3 minutes that you get. Now, it's not only the direct outcomes of your PhD work that are important, right? It is doing a PhD study as such that also teaches you something. So whether you are doing a PhD in electrical engineering or in social science or in whatever, there are a few things that you learn beyond the actual topic that you're studying. For example, presentation and public speaking. These are called transferable skills. Hang on, I need to... Sorry, to clear my throat there. So when you go to a conference or you have some public engagement event, you learn how to present your work, how to present yourself, how to speak in public. You learn how to manage your time. You have 3 years, 3.5 years to graduate on time, or maybe you take a bit longer, but you still need to manage your time. There are many things to be done. So juggling the various responsibility during your PhD study is an impressive achievement. And it is something you train, and it is something that once you finish your PhD, future employers will see that this person was able to finish their PhD, that this means they have some skills in this respect. Networking, you have your chance to meet experts and professionals in your field. Of course, starting with the department, right? One of you said, one of our own lecturers is one of their idols. So you've already met them, right? Your networking has started. When you go to conferences, again, you get a chance to meet many other people, peers your own age, but also people who are further along in their career. So it creates a network for you. Right? You can fall back on that. You can use that in the future. Teaching. You may have a chance to sign up as lab demonstrator, or even if it is not really official, you get involved in supervising an FYP, a final year project student, we call FYP, or maybe you work together with a master student, and in a way that also gives you a supervision task. So teaching and supervision, those are things you train as well, right, to teach, which is a very useful skill. These were 4, right? Sorry, these were 4. 1, 2, 3, 4. Public speaking, time management, networking, teaching. Can we come up with 10 more transferable skills, things that you learn while you are doing your PhD beyond the actual topic? So things that you would not write as outcome in your thesis. If you write it as outcome in your thesis, it is not transferable skill, right? It is really the outcome of your study. So 10 more examples. Simulation. Oh. Simulation technology. Yeah. Writing skills. Yes. Right? You practice that when you write your journal, when you write your thesis, etc. PR, you need to sell yourself. Yeah. Critical thinking, very good. Programming, if you have that in your scope. Digital communication, coding, same as programming. Professional attitude, right? Data management, very good. Problem solving. Teamwork, yep. Logical capability. You mean logical thinking, right? Adaptability, scientific argumentation, reasoning, right? Resilience, so more on the personal attributes. Collaboration, yeah. And here in the other chat, data analysis, knowing about innovation in the world, ethics, yes. Bridging real-life engineering problems, theoretical aspects. Communication, I think that was already given. Management, leading a group, so management skills, yes, very good. Long-term planning, right, related to time management, but you make it more specific in long-term, that's good. Academic thinking, yes. Decision making. Good. English, Yeah, your linguistic language skills. Yeah, very important. Analytical skills, systematic work, right? Project proposal management. Okay. Would you say project management? Patience. Yep, yep. So that's another of the really personality things. Yeah. Synthesis, stakeholder engagement. Right. So that's a very specific kind of communication in a way. Right. Hmm. Lifelong learning, a very important personal skill. Yes. Approach differently. So by approach differently, you mean something like if it doesn't work the first way you try it, you try something else to make it work? Is that how I should read that? Budgeting, hmm systematic analysis, self-improvement habits, right? Self-grooming. Self-grooming. Okay. This is to go and meet with stakeholders, maybe? Tingaram? Stress management. Yes, absolutely. PhD stands for permanent head damage, right? Mental and emotional control. Yes, very important. Less sleep, I see here. Um, various techniques. ISO standard for testing. Yes, those are so some of the professional standards, right? Codes and standards. Yeah, very important. Continuous learning, so that's lifelong learning, right? Competition, vision oriented. Okay, vision as in mission and vision, not as in visual. Tolerance, yes, yes, you have to work together with other people, so you need to tolerate them. That's a thing. Yeah. Collaboration, networking, benchmarking. That is an interesting one. Yeah. Competition. Mhm. Build an innovative nation. Well, that is a very, very ambitious transferable skill. Yeah. Perseverance. Yeah, I think we've seen that one. Interdisciplinary. Okay, we have way more than 10 by now. So thank you very much. Yeah. So there are many things that you train, many things that you learn. Cross fields, interdisciplinary. Very good. Some of them are really personal, right? Perseverance, patience, tolerance to others, etc. Some are kind of personal, but also useful in your. I mean, they're all useful. Um, you're dealing professionally, so team management, project management, yeah, and some may be really technical data analysis, um, coding, right? Right. How to analyze papers correctly. Mhm. All right. So, how does research work? Of course, research in general, right, uh, is a cycle. You think and plan. You think there's a problem. You plan to solve it. Maybe you discover something. You gather, analyze data, which then you write and publish, which you share, impacts others, and other people are made to think about it, plan their own, and so the cycle continues, right? Why is this important? Because we said in the beginning, research is not just gathering data, right? If you only gather data, you are here. But at the very least, you need to push it to the next, right? Because it needs to be part of this circle. So you need to read, you need your input, you need to read, you need to go to conferences to listen, whatever you do, you need to generate something, and then you need to pass it on so that the circle can keep on going around. Circle is round, so that the research can keep on flowing in a circle. So for your PhD work, can you share with us, as I said, today is very activity heavy, 10 sources where you get ideas for your PhD? Previous research, previous articles, so papers, books, seniors from the lab. Okay, so we already have two very different ones, right? We have just the paper-based, and we have the seniors from the lab, which is human beings. Right? DeepSeek. What is DeepSeek, Lindsay Howe? Predecessors research. Yep. The problems that arise. Okay, so we can take the data, etc., as input, but we can also just look at a problem and use that as inspiration to get started. Yes, so it's a really different approach. Same as ChatGPT. Oh, okay. So the large language models. Okay. The web, okay, that's very big. Energy audit reports comparing solid state and remelting. Okay, so this is very specific. Good. Experience. Real life engineering challenges. Global problems. Industry challenge in real world engineering problems. Yeah. Community experience. Person with disability using rehabilitation technology. Okay, so this is, you mean a kind of interview, questionnaire, feedback? Web of Science, okay, so that's where we find the research articles. Industrial standards, this is a different kind of publication, right? Technology trends, and where would we learn of the technology trends? How? Google Scholar, yep. Website Frontiers. Supervisor, yeah, that's always a good source. Find the research gaps. But I want to steer it a little bit back because the question is sources, right? So okay, you can read a previous study to look for the gaps. So the previous study is the source. Yeah, that's right. Problems unsolved from daily life. Review paper. Conferences. All right. So we have a lot of publications, whether we just say paper or review paper, or Web of Science, Google Scholar. So it's all paper, but also industry publications, right? Technology trends, industry trends, Standards, those are more industry-based. Human-based, people you meet at conference, your supervisor, your lab seniors, and so on and so forth. And we have the problems. So look at it from the problem side. All right. Good. Good. Okay. So in general, when we have a research, right, we start with what's the problem? Okay. What is it that we want to achieve? So what is the topic? When we have defined that, we are going to review the literature. Because we want something new, right? If it's already published, we cannot. So we need to familiarize ourselves with the existing research on the topic. Once we know what we are exactly going to do, and we have scoped it with the help of the literature study, we need to make our research design, our methodology. Right? So choose one or more research method. We can make use of existing sources if there is still new knowledge possible to be extracted from it, or we need to generate our own. Then we formulate our hypothesis. So we think we can improve something by changing a variable, or we think that some variable has an influence on something, etc. Right? It depends a bit on your field. Then it's time to do the actual work. Not true, this is also actual work, but this feels like the actual work, right? Collecting the data. Interpret, get its very own box, even though it's the smallest. But interpreting the data is very important. Not just collecting, also interpreting. And then finally, sharing it with other people. Okay. It's given here as a one-way flow. Because hopefully for your PhD, that's how it is, right? You get only 3-4 years if you want to graduate within a reasonable time. So you don't really have the time to do this and then think, oops, I made a mistake, go back here, because that will take a lot of your time. So we want to, as much as possible, follow the flow and not do too many iterations. But it doesn't always work like that. So here we see basically the same thing, but now broken down in steps. Identify the research question, right? Then we do an initial review of literature. Because we need to identify our research gap, right? We need to see whether there is really any need for the research. So we need to do an initial review of literature. And you will see this back in a PhD thesis, right? In a chapter 1, there is a bit of literature review. Not much, but a bit, just to help you support the research gap and so on. So that's the initial review of literature. When you have a good enough idea, you can distill the research question into a researchable problem. Right? Continue the review of literature. Then you formulate your hypothesis, your research objective, your research aim. Okay, see, they are written here as 3 different things: hypothesis, objectives, aim. And we will see in the rest of the course, especially aim and objective are very often confused. So you ask a PhD student, what is the objective of your research objective? And the answer they give is actually telling you what's the aim of their research. So pay attention later when we come to that chapter, that you really separate what is the objective, what is the aim of a study. Okay. Once we're here, we go into the basic research approach. So this is what kind of study are you going to do, right? What type of methodology is going to answer your research question? Do you need to do a population study? Do you need to do experimental study? Do you need to do a simulation study, right? Just your basic approach. Then you need to identify population and sample. How many, how many especially. Then you design your data collection plan. So that will be, then comes more detailed methodology. What experiments you're going to do, etc. Okay, once you know that, you can hopefully use whatever equipment is in the lab, but if not, you maybe need to make some setup. So you are going to develop your data collection instrument. Once collected, you need to analyze the data, so you need to have a method for that. Once you've done all this, you can go into the lab and actually implement the research plan. So here is where you collect your data, 11. Interpret the results, so doing the analysis and conclusions, hopefully. And then it's the decision point. Did you achieve your objectives? Where were they? Here. Did you achieve your objectives? Yes. Then you can write your thesis, publish your findings, and graduate. Did you not reach your objectives? You need to try again. Well, for PhD study, we don't really want that because that will make it last twice as long. So it is possible sometimes to tweak your objectives a little bit to make it seem that you achieved them, or you just have to write in your thesis that you didn't achieve the objective. That is not really going to go down very well. So we want to avoid this, right? Avoid this. Okay. So fundamental steps. I hear somebody. Someone has their microphone open. I don't see it right now. Okay, never mind. Okay. Among the steps in the previous slide, which one is the most critical? Means you can't afford to make a mistake there. Which one is the most critical of the steps in the previous slide? And why? The formulation of clear objective, because it will define the rest of the PhD, the study. Item 3, what's item 3? Researchable problem. Okay. The research question is what? Formulation of hypothesis, because the decision at the final stage depends on whether the hypothesis is found to be correct or not. I just finished the sentence for you. Research question is the most critical. Most important step is identifying the research question, because it focuses on the whole study that helps you stay on what you are trying to find out. Review of literature to better understand the state-of-the-art research and what else could be done to improve or change. I see nobody is typing anymore. So we all agree with this, or step 1 to 3 are the most critical because the research question is the foundation of the entire study, right? Step 1, identifying to know whether the research is feasible or not. If the question isn't right, nothing else will be. Yeah, that's true, right? Step 15. What is 15? Publish the findings. Yeah. So, like Rosalind says, the beginning, right? If the beginning isn't right, then whatever follows is not right. But you approach it from the other side. You say, if you don't publish it, then you have done it all for nothing. Yeah, that's both very valid ways of looking at it, of course. Poorly defined question will lead to flawed research, design, and unreliable results. So it's the question, right? Step 1, it gives us the direction. So most still would seem to say the beginning of the whole process is the most important one. Get started correctly, get the question, get the research hypothesis, maybe the research objective all correct, because then you can make the rest follow from there. Right. Okay, good. Good. Let's continue. Now, there are different types of research. I already slightly hinted it just now. And it's based on different things. You can have different purpose. You can have a very basic, so fundamental research. What you see in the science faculty, physics, studying elementary particles or things like that. It doesn't really have an application directly. It's just to learn things. So very basic. Or what we see more in engineering faculty, of course, is applied research, where we're looking more at, we want to solve a problem, create something to use. So very different types of research based on what is the purpose of it, the reason behind it. We can also look at different designs. Are we doing an exploratory research? We're just testing the water, maybe feasibility study, for example. Or are we trying to get some very conclusive final answer? Right. It will be a different kind of research, right? What is the nature of the research? Is it descriptive? That means general terms, right? General trends, general terms, etc. Or is it very analytical, very detailed, very maybe smaller field of applicability, but more in depth? How do we collect the data? Is it quantitative or is it qualitative? Of course, we love quantitative data. We have numbers, we can do statistics, and so on and so forth, but it's not necessarily always possible, right? Sometimes some studies are just qualitative in nature. What's the approach? Are we doing a deductive study or doing an inductive study? These are terms from logic, right? I think they're on the next slide. So here we see again a number of types of research. Fundamental and basic research. So science, basically. Case studies. Case studies are very, very special because a lot of the variables are not under our control, right? The case has already happened, so we cannot tune the parameters anymore. It's already fixed. Descriptive research. Survey, conclusive research, analytical research, quantitative research, qualitative research, applied research. Okay, these two belong together, so I should not have started here. These two belong together, right? These two belong together. Not so much. Okay. So if we look basic versus applied research, we see in basic we find pure fundamental research, right? Where we are targeting discovery of new knowledge, theory. So it's also theoretical in nature. The purpose of basic research is not really to find something that has practical utility. So it may take years before the results of basic research find practical utility. Or maybe they never find practical utility as such, right? And it's also not necessarily clear directly how they have practical utility. They're just your background knowledge. When let's say Watson and Crick did their research into chromosomes, right, genetics, they weren't targeting genetic manipulation. They weren't targeting gene treatment therapies for diseases. They were just doing fundamental research. Of course, without that knowledge, these practical uses would never have been possible. Right. So that's basic research. Applied research is kind of the opposite, right? The central purpose of it is to solve a problem. An immediate problem, or at least an existing problem, solve a problem. Or to improve a product or a process, which you could say is still a problem, right? Because the problem is that the improved product didn't exist. We want it to exist. The interpretation of results relies on the basic research. If we never studied any physics, chemistry, mathematics in our foundational studies, we couldn't do applied research, right? We need the basic research to give us the tools to do the applied research. Okay. Quantitative versus qualitative. Quantitative research works with structured data. And especially those of you working with machine learning will probably be nodding now because you need your data to be structured, right? Statistical analysis, because, well, machine learning is statistical analysis. Doing so, we hopefully reach objective conclusions. We generate our data, maybe by surveys, maybe by experiments. Qualitative works with unstructured data. And that means statistical analysis is simply not possible. And if statistical analysis is not possible, it's very hard to reach objective conclusions. So conclusions have an amount of subjectivity. That doesn't make it wrong necessarily, but it's a different type of conclusion than for quantitative. You shouldn't use it for the type of study where quantitative research is more logical. How do you generate this unstructured data? For example, by interviews. That's different from survey, right? Survey, we try to give questions in a very specified format. On a scale of 1 to 5, rate your experience with blah, blah, blah. So your answers are going to come in 1, 2, 3, 4, 5, which is structured, and you can do your statistics. Interview is like, could you share with us your experience on ... That's unstructured, right? You ask 10 people for their experience on something, you can't add it up, you cannot average it, you cannot do any statistics with that. But it is still very informative. You can still draw subjective conclusions out of it. Okay. I think in most of engineering, we would be dealing with quantitative research. Maybe exception in things like safety and health. I think that would be probably the major exception. Yeah. Or also, you say accessibility issues and so on, right? For people with disabilities. That may also have some qualitative element. But generally for engineering, we're looking more into quantitative. But I should ask you, what type of PhD research are you planning to conduct? You, that's the key word here, you. Is it quantitative, qualitative, basic, applied, etc.?
Hello, doctor.
Yes?
Can I ask you a question?
Yeah, of course.
Case studies is considered as qualitative or quantitative?
Sorry, can you repeat that?
Case studies is considered
Yes.
as qualitative or quantitative research?
Okay. Case studies. That's not really in that dimension. So I would say it depends on how you do the case study. Yeah.
If I
So-
make comparative study,
A comparative study?
yes,
Okay, so if you base your comparison on numbers, it will be quantitative,
Yeah.
right? So if
Yeah.
you say you compare class A with a class B and you list the length, price, energy consumption, whatever within the classes, you're doing something quantitative. But if you're going to interview people kind of free form about the different things you want to compare, then you're doing a qualitative study. So it's not really it's not really like that. You have to see it as as this, right? Based on something, we have different between basic and applied. So it does not mean that basic research has to be conclusive, has to be analytical, has to be quantitative. This is like one axis. This is another axis. Okay?
Yeah, I understand. Yes, yes. Thank you, doctor.
All right. Quantitative, both quantitative and qualitative combination, applied, quantitative, mixed method, applied, qualitative, applied, a lot of applied. Case study, mixed method. Anyone going to do fundamental study? I said engineering normally applied, but it's not necessarily true, right? Let's say you do chemical engineering and you want to find out the kinetics, so what is the order of a reaction XYZ? That's not applied, right? That's purely fundamental. But that would be more science than chemical, chemistry than chemical engineering. Anyone doing fundamental research? No. Yes? Applied and quantitative. Okay. All right. That is very clear. That was quick. Deductive research versus inductive research. So deduction in logic is the type of reasoning that when premises are true, the conclusion must also be true. Whereas inductive research, known premises are used to generate untested conclusions. So how this works out is usually that we have a generalization. Is it generalization? Going from the general to the specific. So the standard example for deductive reasoning is all men are mortal, right? All men are mortal, that's a general statement. Socrates is a man. That makes it specific because now we can draw the conclusion Socrates is also mortal, right? So we started with a general statement, all men are mortal. Socrates is a man, so the specific outcome is Socrates is immortal. Definitely true. So it's deductive true. If we want to do this kind of research, we are looking into survey and theory falsification or verification. Okay. Inductive research, we're generalizing from the specific to the general. We have analyzed millions of people. We found that eventually they all die. So from there, we conclude that people are mortal, right? So we go from specific, but many of them, and eventually we draw a general conclusion. So this is how we generate theories and how we build theories. I would think most of our research is inductive because going from the general to the specific is not really that exciting, right? You already knew that. But going from specifics and trying to formulate a generally valid principle, that's exciting. So I think we have more inductive research than deductive research. Okay, we're about halfway the time. It's 10:30. I propose we take a 5-minute break. Then we can stretch our legs, go to the washroom, drink something. I'll see you back at 10:35. Okay, let's continue. Explain the potential outcome of your PhD work. So of course you're going to do publication, maybe you are going to apply for patent, but now looking more at other outcomes. So how is it going to impact? So maybe impact would be a better question actually. Improve EV charging. Okay. So you mean make it faster, Kanich? Or make it last long, the battery last longer, or how? Improving fees. No. Charging method. WPT. Oh my goodness, what is WPT? Improving efficiency of perovskite solar cells. Okay. Wireless power. Oh, wireless. Okay. Power transfer. Yeah. Improving heat transfer using, I think you said nanofluids earlier, right? Or nanomaterials. Grid reliability. New type of absorption material. Optimization of existing national power grid systems. Improve the quality of diagnosis and treatment of cerebral palsy for children. Stability of perovskite solar cell. Okay. Actually, because when you're doing applied research, this should be an easy question to answer, right? Because your application is the outcome of the research. Your outcome of the research is the application. Accuracy improvement, mobility improvement. Okay. All right. So we have different research method. We can just do observation. Usually not for engineering, but there are fields of study where you don't really have much choice. You have to just do observation. For example, you study geology or paleontology. You just have to go to the rocks and look at them, right? Sure, you can take samples. Of course, you're going to take samples, bring your samples back to the lab, etc. But you're not designing experiment in the sense that you say, what if the pressure in the Earth crust was twice as high? And what does it look like after 200 million years? That's not a feasible experiment, right? You cannot change the parameters. The Earth crust is already there, always has been. So you can only observe. You cannot manipulate. For engineering, usually not necessarily the way, but okay. Questionnaires and surveys, right? So when we work with humans, this would be the way to get quantitative data. Interview and focus groups to get qualitative data. Case study, a little bit like observation, because you cannot manipulate the parameters, right? You just have to study what's there. The case is there. Yeah. Experiments, so that it gives you the full freedom to manipulate variables, and at least if your equipment can handle that. So if you want to know what happens at a certain pressure, or certain voltage or whatever, you can set that and do your experiments. Really lab work normally. Secondary data analysis. Very interesting. You can just take data that's already published. Normally, we do not do this for 100% of your PhD thesis. That will be a bit odd. But it's very common, for example, for people to develop a simulation model and then validate it against published data. So you say, if we simulate these and these conditions have been measured by somebody else, it is within so many percent. So you're using somebody else's data to still support your own study. I guess that's a form of secondary data analysis. Or you see meta studies. You see this a lot in medicine, isn't it? Where people have done population studies, and once there are a lot of population studies, somebody comes along and does the statistical analysis by trying to combine all of them. So the secondary data analysis. Mixed method, it just means you mesh together some of the above, right? Which is very common, because even if you have experiments, you also have some other sources of data. Or if you do a case study, you probably want to do some experiment as well to validate a certain theory that you develop based on the case study, right? So it's common to mix and match these methods. Okay. Characteristics of scientific research, right? Because even though we are not in science faculty, we still have to adhere to the scientific standards for research. So the purpose of our research should be clear, right? We clearly state what is the purpose of the research. It should be oriented to a solution, not necessarily application, but solution. There is a research problem, there is a research question. We want to solve that. So the research is oriented to answering the research question, solving the research problem. If not, the research will also not be systematic. Right? This is part of being systematic. Determine the relation between two or more problems. Careful skill in reporting and recording data. So actually, whatever we do, right? Whatever we do, there should be the relevant skills should be there. If you do not have the skills, you should either learn them or collaborate with somebody who does, so that there are no questionable things happening, right? That goes from setting up your experiment till generating the data, analyzing the data, somehow missing, reporting the data. Everything should be done with the necessary skills. You should have a knowledge of your research problem. And again, if you sit in a lot of Vivas, eventually Hey, why do I hear myself? You can hear students who seem not to be aware of what's the actual research problem. So that cannot be, right? Part of systematic is that you know that. Yeah. Replication. Research is replicable. That means when you publish it, it's done in such a way that anyone who reads your publication can understand your background, understand your methodology, the design of your experiment, the procedure, and can replicate the results based on that, right? This allows research to be validated. If things are missing from your descriptions, right? Sorry, you do not disclose where you got your samples or how you tested things, etc., etc. Eventually, it is not scientific research anymore. It's just a statement of a conclusion, right? It has to be falsifiable or verifiable, and that means it should be possible to replicate. I think we all knew that anyway. So some characteristics of good research work is systematic, right? We started with that. That means it's structured, done in a specified sequence according to a well-defined set of rules. Right. Maybe you are the one who will define your set of rules. Maybe you follow an accepted set of rules from literature. That's fine, but they should be well-defined. So that's systematic. Second is empirical, related to at least one aspect of a real-life situation. Critical, provide clear and precise judgments. Conduct the research without any bias, sorry, by following systematic procedures. So then it is methodical. And you should have integrity, so follow human rights and correctly report any flaw in your findings, any flaws and any findings. So no changing of data, right? And no harming other people. So that's integrity. Logical, the principle, the reasoning, process of induction, deduction, you should all follow accepted logic, right? Logical, yeah. Replicable, we just discussed that. Feasible, practicality of research problems, availability of subjects, money, resources, should make it possible. Otherwise, you cannot do good research, right? If you say, yeah, I would like to, well, give an example. I would like to test 100 samples, but it costs 2,000 to test one sample. Money is going to be a constraint. You end up testing only one sample because money ran out, then you don't have good research work, right? So your research plan from the beginning also should take into account what is feasible. How much time do you have? How much money do you have? Consumables in the lab, etc., etc. Cyclical, we saw the circle earlier on, right? You take the knowledge and the from the previous step in the cycle, you identify a gap, you try to fill the gap, and then you pass it forward. So you solve research problem, you answer some questions that are now still unanswered, and then you create opportunities for future research. So you should be part of that cycle. Nearly towards the end of this set of slides, what is your motivation for doing a PhD study? Your personal motivation. I mean, this can be anything. To become a specialist. Mm-hmm. In my domain, all right? Expertise. better opportunity, open up more career path, better opportunity for career path. So those are very life oriented, so to speak, right? For your own future. Learn deeper skills, become a specialist, improve my professional skills. So it's more towards the curiosity, right? You want to achieve something. Contribute to making a positive impact on the environment. So you're more seeing a PhD as a way to, well, as you said, have a positive impact. Right. So solve real problems in my field. It's related to that. Career improvement again, okay. Professional personal values. I'm going to kind of put that together with the career improvement. It's more a self thing. Personal satisfaction. Role model for kids. That's interesting. Yeah. Benefit of collective. Become a university teacher. So yeah, that's definitely a career path that becomes, or that opens up when you do a PhD. You want to get a Nobel Prize. Okay. Don't forget me when that happens. It's my responsibility. My responsibility to contribute the best solution to my community. All right. So this is, I think, the positive impact again of the outcomes of the research itself. Step to inspire future engineers. Right. This is similar to the role model. Okay. So we see a few very different things. Part of the circle, the role model is really being part of the circle, the ongoing things. Missed out on studies earlier in life, so now I'm pursuing lifelong learning. Yes, it's part of lifelong learning. Even when you do your PhD at a younger age, it's still part of lifelong learning. Yeah. Challenge myself. Yeah, very good. Upgrade our body system. Is that going to be the outcome of your research, or is that like transferable, something that happens to your body because you work so hard or something? Self-development, I guess. Upgrade and expand my knowledge, or for myself, not about myself, for myself. Right. Because my father always got insomnia, and many other people too. So your research is about insomnia, right? So you have a personal motivation in the research question, right? Catch up with latest technology. So a lot of motivations to do your research. I hope everyone has a good motivation, because it's not always going to be plain sailing, right? There will be some disappointments, times when you get stuck, when nothing seems to work, etc. So it's important to have a motivation to be able to tell yourself, well, I still want to do this because all the things you typed just now, right? I will overcome this nasty period of things not going my way because all the things you typed right now. To become a specialist in a certain area in academia, as well as improve my professional career. Yes. Okay. Let's move on. So what does it take to be a good PhD, successful PhD candidate? You need to be accountable. I'm sorry for the colors. The blue is a bit too dark. Accountable. That means people can rely on you, right? If you say you're going to do it, you are going to do it. Good communication skills, because you have to communicate with your supervisor, with the community, with your lab mates, with your lab technician, with whatever. So you need good communication skills. Motivation, we saw it just now, right? Very important, maybe should have been the first one. Because without motivation, all the other things may fall apart. Hard work. You have to work hard for a few years. Well, that's not bad. You have to be able academically, because there is technical knowledge, analytical thinking, right? Which requires you to be able academically. Persistence. Well, we've seen the word a few times today, so I think you knew that, right? If you give up, then you're not going to reach the end. So you cannot give up. Ability to think together with academic, right? Passion. Maybe goes a little bit with motivation. Passion. Time management. So very, very down-to-earth skill, right? Open-mindedness and curiosity to learn something new. With your motivation. Others. All right. So looking at yourself, hopefully you have most or all of those 11 things, or you're willing to work on them. So those are the things that a PhD student should have. What are the things that a PhD candidate should avoid? What characteristics or behavior that a PhD student should not have? Procrastination. Lazy, right? Forgery, so dishonesty. Yeah, cannot. No. So integrity is important. To give up earlier, right? Because we must have this persistence, right? Shy. Yeah, there's a thing. You need to be, I mean, it's introvert. Yeah, that's a character thing, but maybe you need to force yourself to meet supplier, supervisor, test objects, subjects, and so on and so forth. Close-minded. Yeah, we have to be open-minded. If close-minded, we cannot accept the outcomes of our research and so on. Delay. So that's again the procrastination, right? Poor time management also goes towards there. Another delay. Depression. Right. You should make sure that you keep happy. Right? Even if things do not work as you want them to work. It's frustrating, but cannot get depressed. Frustration and depression are two different things, right? Adhere to planned tasks, right? Undisciplined, so there should be discipline. Academic cheating, yep, so integrity should be there. Lack of time management. Bias. Bias is also a very important thing. Sometimes hard to detect. Refuse to communicate. Dishonesty, we've seen a few times. Lack of self-confidence. Right. That would be very that would be holding you back, right? If you have a lack of self-confidence, that would hold you back. You cannot have that. Narrow-minded, yeah, that's Discouragement. You mean easily discouraged? Or discouraging other people? Lack of independence, lack of self-direction. So you need to do it yourself. Initiative, I guess, also. Time and stress management. Yeah. Poor relationship with supervisor. Characteristic. How would you get a poor relationship with a supervisor? What personal characteristic will give you a good or a bad relationship with your supervisor? What can you do about it? Working in isolation, right? We have to work together. Autism. I'm not sure what you mean by that. I'm sure there are many very successful scientists who have some form, some level of autism. There are many different shades of autism. Of course, hyperfocus is one of the characteristics, right, of autism, which can be very helpful in focusing on a PhD. So I'm not really sure whether I should support that autism. Not doing all experiments by ourselves, but using technician and UG students. Well, collaboration is actually very important, but of course, using other people is normally considered not ethical, right? So collaboration, you have to be fair to everyone. Yeah. Time management between study and family. Forgetting to celebrate small wins. Absolutely. Self-motivation also means not focusing only on the problems and what goes wrong, but yeah, celebrating small wins to get to maintain the good overview of your progress, right? Because I think we saw discouragement earlier. So if you do not celebrate your small wins, you might get discouraged by the problems that you have. Overthinking. Yeah. Overconfidence. Everything over is not good, right? Correct. Expecting spoon feed. No more spoon. No more spoons for PhD students. Right? This is the thing, right? Just now you say poor relationship with supervisor. Here's the thing. Supervisors will want you to discuss things with them. If you do not discuss things with supervisor will complain and say the student never comes to see me. But if you go and see your supervisor every day asking what should I do, how do I do this, how is that, expecting to be spoon-fed, your supervisor will also be very annoyed with you. Right? So yeah, you have to, maybe you have to learn or you have to know how to approach a supervisor, what things to expect from your supervisor, what things does your supervisor expect from you. Yeah, very important. Avoid imbalance between daily life and PhD work. Yes, your PhD work is demanding, so you have to set the boundaries. Yeah, important. Okay, good. Thank you. So Finally, I think for this this topic, this module, we take a look at the MQF. MQF is the Malaysian Quality Framework. This is the framework that governs from the Ministry of Education, Higher Education, the quality of our degrees and diplomas. PhD is considered level 8. So this starts at preschool. Master is level 7, PhD is level 8. That's why this course is also KVX 8001. So the 8 there is this 8 here. And the requirements for a PhD graduate, according to the ministry, is that learners will demonstrate critical understanding of the most advanced knowledge at the frontier of a field of study or professional practice. So there are two elements here. You should be at the frontier, the most advanced. That's basically the same thing, right? And you should have a critical understanding of that. Not just understanding, right? Understanding is for lower levels, but we should have a critical understanding. That means, why is it like that? What does it mean? How can it be used, right? Those are critical analysis questions. Second is independently conduct, manage, lead advanced research which contributes to substantial new and original knowledge and our professional practice. So the keyword here is independent. Yes, you have a supervisor. In many countries, it's not called supervisor, it's called a thesis advisor, right? Because they want to highlight that the PhD candidate is the one responsible for the study. The faculty staff, the supervisor in our case, is just there to guide. But the responsible person for the research is the PhD candidate. That's what you should develop, right? Of course, you're now just a PhD candidate. You're not a PhD graduate yet. So now you still have some supervision. But once you graduated, I see some of you put in your career path, you want to be academic staff. You need to be able to do it independently, completely without supervision, right? So this is the time to develop that. Produce research output in the form of, well, obviously thesis, sometimes patent, product. Where are the research articles? I don't see them here, but this is what the ministry says. Right? Finally, demonstrate capacity to present and defend points of view. So this refers to, like, let's say, conference presentations, seminars, etc., and also your thesis defense, so your viva. So you need to be able to articulate your point of view. We do a lot of that in this course, right? This is not necessarily related to your studies, right? This is just a personal capability. Your thesis, yes, that is related to your study. Ideas, ideas in the area of expertise with knowledge and confidence. Right, you're not just saying whatever because you are good in saying whatever, presentation skill. You actually know what you're talking about, obviously. Okay. That is it for this module. What are the main take-home? So every week after the module, I have a reflection, but the question is always the same. What are the main take-home points from the session today? It's not an activity in the sense that you have to write it right now, but it is good to close by thinking, okay, what did I learn? How can I use it, etc. What do I take home from it, right? Is it going to affect what I do in the lab, or have I just spent a few hours for whatever reason? Right, it's up to you, but you have to reflect on it. Okay. Thank you for this. Don't go yet because I want to go through the Spectrum page, but for this module, thank you. I prepared these slides, but it was made after an example by Prof. Aziz, Dr. Archina, and Ms. Adila, with public domain pictures as much as I could find to make sure I do not infringe on people's copyright. Okay, so as I said, I want to show the Spectrum page that is here. Come on. So now you get to see my view of the Spectrum page, which is bigger than yours because there's a lot of things not yet visible to you. That's okay. They will become visible as needed. Okay, so don't worry that you cannot see certain things. That is by my choice because I do not want to open everything at once and then you get confused. Okay, there's course information here. Where you see the course planner and the lesson plan. And I should have opened them up. Okay, I will do that now. It will take a while. It should be on my computer somewhere. I don't know where. So you can take a look at those. There will be announcements. Are there announcements? There are no announcements. Okay, that's fine. You see there's a few things hidden from students, so you cannot see that yet. One thing is we will have weekly presentation. That means each of you will get 3 minutes during one of the lectures, not everyone at the same lecture, to present the title, the objective, the methodology of your research, right? Yeah, in a few minutes, we will try to set for next week. I need about 8, 9 people to start next week. After that, I will put the list here and make it available. And by now, let me okay. Yeah. Some things here. There will be a number of assignments. I will speak about that shortly. You cannot submit yet, right? That's why they're all hidden from students. So don't worry about that. Here's your attendance. Okay. So you can click this link to do your attendance. Probably you can also do something with this QR code. So if you go to attendance for today, you can see who has self-recorded their attendance and who didn't. Or maybe you can't. I can see that, but you can do your attendance. Here, every week, I will make available the module of that week. So for today, the PDF is there. If you want to see it full screen and you have problems getting that through Teams, you can download or you can, review the slides later if you want. As I said, 11 modules in total. Okay, then I have for you the one I just downloaded, which is first the course planner. Normally we should start with that, but since initially there were not that many people, how do I make this? Oops, I need to update this. Research methodology. Okay, this is me. I need to update this as well. That's my room. So it's fully online. All right, our course is fully online. So I know the Maya says DK7 or something. Forget about that. There will be no one there. We're fully online. And the assessment is 100% continuous assessment. So there's no exam. There's also no written test, or that will still be continuous assessment, but we don't have any. Okay, so here we have the 11 modules, and after the modules, I think there's 12. After the modules, we have proposal presentation. Yeah, or poster presentation or whatever. Then should be one more. So lesson plan. Okay. Oh, I should update the dates. I did not update the dates. So we have our modules and so on. But here I've also included the assessment. So I will get a lot of questions about this, but let me do it anyway. This is not necessarily related to the week where it's written at, but we have a 10%, for the verbal presentation. That means your weekly presentation, the one I mentioned just now, right? We have a 50% of your marks coming from the final report that you submit. So write a research proposal based on your research title, starting not this week, some later week. I will start giving some subjects to be included. So you write it bit by bit, but you submit at the 12th week. Okay. This will be marked by the course lecturer. I don't have any independent examiners. It will just be me. Okay. So this report or proposal is for this course, research methodology. You also need to send a report to the faculty for your proposal defense, right? Which is also proposal. Right. You can definitely use the same material for both reports, not an issue at all. But this report is not the report for your proposal defense. This course is not related to your proposal defense. Okay? They're separate. This one, KVX 8001, is a course, a subject you need to pass, and the report is part of it. Proposal defense is one of the activities or one of the milestones in your candidature that you need to pass. You need to submit a report. They're not the same. Okay? Don't confuse. Every semester students confuse. these reports are not the same. You want to copy paste text, I have no issue. Okay? But if you submit here, it will not be seen by the Deputy Dean's office for your proposal defense. You submit for the proposal defense, I cannot see it here. So be aware you need to do both. Okay, so we have seen 10% for your weekly presentation. 50%, so we're at 60. Then we have, where are we? Okay, a poster, another 10%, so we're at 70. Then we have, what is this? Oh, there's an artificial intelligence certificate, which is another 10%, so it's 80. And then we have a 3-minute presentation, again, for the end of the semester, where you just show your research proposal, right? The full proposal. But it will be short because we have to allow 70 of you at the moment to do that. So there will be another 10% for the video and another 10% for the slide that you use in the video. Okay, so that adds up to a total of 100%. So you can see the proposed weekly breakdown, only I need to adjust the dates for this semester. These are last semester's dates. I am so sorry, I forgot to do that. And these are the activities and the assessments during this semester. Okay, I hope that's clear. Yes, you want to ask?
Do you have any specific template for a presentation, or we just can use any of them?
I'm fine with any. I do not make any demands on that.
Okay.
Very good question. Yeah. There's one thing I would like to say though. If you want to use the university logo, there is, if you go to your Maya portal, I think, there is an item brand toolkit. I have a different view because I'm a lecturer, so you have your student view. But somewhere there is a link brand toolkit. If you want to use university logo, etc., look for that one, get the latest official logo. Don't Google image University Malaya logo, and then sometimes I get to see logos of 10, 15 years ago. So please don't do that, okay? We have official brand toolkit. Use it. You practice it now, later you go for conference, you have the right one. Okay. So we don't have to embarrass the university. The weekly presentation for 3 minutes, there will be a schedule for that. If I ask everyone, then 70 times 3 minutes is 210 minutes, right? Which is 3.5 hours, which is more than we have available. So I will ask a few people per week. I want to make a schedule for that, but not knowing who is active, I haven't done that yet. So we identify the first volunteers for next week, and then I will upload a list for the coming weeks. So I hope that answers your question, Turga. Can the title of my proposal be defend? Oh, absolutely, absolutely. That's what I say. The title logically is the same. It's your PhD title. And the content even can be the same, right? You're not going to develop a set of objectives here that's different from your proposal defense, etc. The only thing you need to take care of a little bit is the word limit for your proposal defense. That's all, right? So don't do double work for the sake of what, right? We try to work smart. Okay, so if there's 2 reports and you can kill two birds with one stone, you absolutely should do it. Did that answer your questions? Okay, so I want to have 9 volunteers for next week's weekly presentation. Well, volunteers is not working, isn't it? If not volunteer, I will assign. Yeah, Raihana. Raihana, Dinagaram, Rizwan, Homin, Muslim, Dongxiang, Yang Hui. 1, 2, 3, 4, 5, 6, 7. Turga. One more. One more after Turga. Singwan. Okay, that's enough. Thank you. Singwan is the last. So for next week, I get presentation from Raihana, Dinagaran, Rizwan, Homin, Roslin, Dongxiang, Yang Hui, Turga, and Singwan. Okay. Thank you very much for your volunteering. Much appreciated. For the rest of the students, I will just make a schedule which I will upload into the Spectrum system. All right, it's a little bit earlier today. It may sometimes be a bit shorter than 3 hours, and maybe sometimes it isn't. It's a little bit hard to schedule exactly with so many feedback slides. Thank you very much for today. It was a pleasure for me to meet every one of you. Looking forward to next week. Please show the slide again for the 3 minutes presentation. Homin, I'm not sure what you're asking. I did not have a slide for the 3 minute presentation. Okay, my expectation is that you just make one slide with your title, your background, what you're planning to do. Okay, I know you're the first batch to do this, right? So you will just have your title, the background of your study, the research question, the research objective, methodology, rough methodology. That will be about it. Hopefully based on feedback. Click on attendance. Yes, you can mark. You can take your own attendance. I showed you just now. Content, 3 minutes. Yes, please. All right. So as I said, thank you for attending. Hope to see you all next week. And bye-bye. Have a great weekend. Thank you.
Thank you, Prof.
Thank you, Prof.
Thank you.